Hello. Hi. Today we're going to be talking about Eve Quasar and kind of the evolution of the Eve network stack. My name is CCP Chimichanga. I'm the technical director for Eve Online. And then I think we're going to take the mic and do introductions and pass it down.
Hello, I'm CCP Mayday. I am the lead infrastructure engineer for EVE Online.
Hello, I am CCP Prismx. I am a senior software developer at EVE Online.
Yeah, I'm CCP Wonderboy, also a software engineer.
I'm a CCP Stroopwafel. I'm a senior software engineer for the ESI team.
And I'm CCP Pinky, also software engineer for the ESI.
So the whole panel that we have here, this kind of crosses all the way down from the infrastructure level to the high level of the network of how we communicate with the client, the servers, how the third-party APIs also communicate into the ecosystem. We have all the people here. We can talk all the different things about that. I just kind of want to introduce the idea and kind of where we've been a little bit. We posted a blog, which was originally called Paint Your Ship Red and Make It Go Faster. This is a blog about how we introduced ship skins, so the character-made ship skins, and how we actually transmit that information for ship skins, and the relationship that has with server ticks and how we actually send all that data everywhere. But to kick this off, ultimately, there's a lot of fun things in this blog post, but the main one was when we had actual tests for this. We had a lot of different, we had about 500 players during a mass test for what we're trying to do. We'll see if this pops up again. But ultimately, what we were trying to do is we were trying to give everybody ship skins to switch between, and we took off a rate limiter in the UI so that players could switch skins as quickly as possible. So we put 500 people in the same grid and said everyone switch skins as quickly as possible, and that means that they could send information to 499 other players as quickly as possible, which immediately set our little potato test server on fire. So I'm hoping these videos will pop up. Maybe it's the luck of the draw for the packets that get out here. But ultimately, you can kind of see in this frame here, there's a animation that happens whenever you change a skin. It's kind of a wave effect that goes from the inner of the ship all the way to the outside. You can see this person is changing it quite quickly. That's probably count the rings on the tree kind of situation. How many times they change the skin? And this would actually transmit more and more data to the server. We have more details in that blog post there about what happened. But because we want this to kind of be a more open conversation, if you guys have more questions about things, I'm just going to try to draw some stuff to give people a point of reference and kind of see where that takes us. So originally, with EVE Online, we have the concept of a soul node. And there's many of soul nodes. So we have probably like, I think 230 soul nodes running on TQ right now. And that ranges from running the actual solar system to alliance services, corporation services, character services, things running systems that are doing incursions, whatever the case might be. So we have many of those. We also have proxies. This is what the clients connect to. And this is basically the traffic that we have internal. Ultimately, you guys have the clients. And for the clients, this is connecting with the original protocol, which is called MachoNet. And this is all pure Python. So this is all Python-based packets that are being sent back and forth. And this is the core of EVE Online, basically these 230 nodes. One of the problems that we run into, and one of the reasons that we started building things like Quasar and ESI in a certain way that we did, was the problem with the soul nodes is if we start adding one, the EVE server is a guaranteed one-hop mesh network. So that means no matter what node I connect to, I'm guaranteed one hop to get to where I'm going. That's super handy for latency, not super handy when you need to actually add more nodes, because now I have to have a connection in between everything. And the more nodes I add, the more connections start coming up, and then I have a quadratic problem of resources, which means that EVE has a ceiling that drops the more we scale horizontally. So the more horsepower we throw at EVE, the fewer players can actually play EVE at the same time on a larger scale. When we did this napkin math, that's kind of where we went, uh-oh, and had to figure out a better way of doing this. So Crest kind of paved the way for this. It's kind of a way to get out of this ecosystem. But ultimately we ended up introducing RabbitMQ, and that is a message bus ecosystem. And with RabbitMQ, that's where we started seeing ESI come online. ESI would then make requests on a message bus that would then go straight into a random sol node. It would just, based on timing of what was processing the message. And then we would actually have those responses flow back out, and then that would come back out to, we'll just put ESI down here. And then you guys would do all sorts of cool stuff with ESI. As this ecosystem grew, we started to realize that, okay, there's more that we can do here. We can start building gateways for east-west traffic. So we built something called the EVE Service Gateway. This is where we started introducing gRPC into our ecosystem and started using something that wasn't directly RabbitMQ, so AMQP protocols, those kind of things. And then we started building more and more services that were just connecting via gRPC to this gateway. That gateway would translate that into RabbitMQ. And then all of our east-west traffic being in networks that we own, would then be processed by the gateway. We then said, that works pretty well. How do we get to this client? So we introduced something called the EVE Public Gateway. And this connects to, that's a lie. This connects to another technology we introduced called NATs. Now, we didn't make NATs or RabbitMQ, to be clear. They are pretty slick pieces of software that are message bus ecosystems. NATs is a very opinionated message bus system, so if you're too slow consuming messages, it will happily disconnect you from the cluster. And this was perfect for what we would expect clients to do. So if any client had to run away, or was compromised, or was sending us bad traffic, it would automatically defend itself. So then we had these connections here. We also had a connection here, and this diagram is going to get crazy. And then the service gateways here. So we had this kind of crossover here. But ultimately, we then started connecting things here. And this connection is the gRPC connection that's out in the wild in the clients, which allowed us to do what we did with shipskins, for example. This is also powering features like corporation projects. It's also powering the Air Career Program, a lot of things since we first introduced it. And this has kind of been the evolution of that. And we're kind of trying to draw a line of where we want to go next, which we want the end game to be something like, oh, people get mad if I don't circle ESI as well. We want the end game to be something like that, where we get rid of all of the old nodes. Now, this isn't going to happen overnight. There's a lot of different things. There's a lot of different data. There's roughly 17 terabytes of data on TQ, and that's anything from character data, probably mostly inventory data, I'm assuming. But what we want to try to evolve this to is to get into more standards like gRPC using protobuf, and then having our east-west traffic basically confined to our service gateway, having our north-south traffic confined to our public gateway, because this allows us to then create more things as we kind of evolve things even further. Like you guys have heard the ESI team talk about, we're looking at doing other interesting things, like detaching into our data analytics team, who have, I'm going to use all the wrong terms. There's a data lake of some kind, you know, where data goes. And, oh yeah, ultimately, what happens is, because we have these gateways, we can bottleneck all of the facts of the universe that are flying around. Because we can bottleneck all the facts of the universe that are flying around, these guys just pour into the data lake of everything that the services are doing, the servers doing, the clients are doing. And then the thing that we're toying with, I think you guys have talked about this publicly, right? Great. Otherwise, my bad. We're then going to try to make a connection to this data lake for ESI because it makes more sense. Because the nature of what ESI is more about historical information, large bits of information, Whereas the systems that are currently at runtime or that are interacting with the client are primarily around what's happening now, with the exception of things like market and contracts and systems like that. We always put limits on those kind of systems of like how much information can you pull down. The interesting thing about this experimentation with the data lake and how we connect all that information will be more around like what can we expose in ESI. We have way more things that we can expose there because ultimately, as you can see from this epilepsy test, that we won't be hitting any of the original Eve server pieces. We actually won't be hitting any of the Quasar pieces either. And so it adds a lot more capabilities to things like ESI, for example. But more importantly, in the kind of green area that we've been highlighting, we want to really push what can we do with this connection here? Like what can we do more and more there? And that's kind of what that blog post is about, to talk more about server ticks. Can we get simulation frames over this connection? If we translate what we did with the test with the ship skins and what we did with 3 potatoes in 3 different cube pods that did the equivalent of TQ's universal traffic per second, and we extrapolated that out, that would mean that we could take Eve to a 90 hertz tick rate from 1. So, this is all a very slow-moving thing. You guys know Eve is a very dense application. There's a lot of stuff going on. Client side, server side, and the ecosystem at large with ESI and various different things. But yeah, this is kind of where we want to start the conversation and see if you guys have any questions. Wanted to kind of poke and prod at some of these things. I can do things like zoom in and out if you want. But that's kind of why I wanted to draw this up here. So if we wanted to talk about more about where these things go, what might make sense, or what would happen if we added or detached some of these pieces, and then just kind of go from there. So then I think we'll just open up for questions. We got one guy right here.
What is the service gateway and public gateway written in? Those are the custom bits of this, right?
Yeah, yeah, that's a good point. So the Quasar in general is our umbrella term for just modern technologies. The gateways are glue. They're gluing together AMQP, Azure Event Hubs, gRPC, and all of that's done inside of Golang. So all of the new services that we're building up are primarily in Golang. We've also migrated some of our older services from existing ecosystems, because ultimately Quasar is just running Docker containers. So we've also been dropping in our older .NET applications into that ecosystem, but making it deploy and look like all the different things that we've added. But primarily we're doing that in Golang.
Yeah, so currently, with the specific Sol nodes, there's the concept of reinforced nodes. How does that then fit in with the new gateway situations? How do you actually then reinforce something for a major fight or a tournament or something like that?
So I'm going to tell you some terrifying things. The Eve cluster, when we run the cluster, it's pre-mapped. All of it's deterministic. This is one of the factors that attribute to character IDs being sequential, solar system IDs being sequential, because in order for us to route to those, we do modulus math to figure out which node we need to go to. It's clever, but obnoxious in modern systems. Now, with that said, we might run JITA in one node, we might run characters in another node, and we might run alliances in another node. Now, you notice I left this guy blank. This is because we cannot increase capacity at runtime, because it's deterministic. But we can collapse capacity at runtime. So if this explodes, we can remap it here. Okay. But we cannot actually expand this out. So one of the things that we want to do, and this starts connecting a lot with data coupling, is that we would like to take the concept of a solar system node and detach it from its very tight coupling with the database and treat it more like, I don't know if you guys remember, there was a project a while ago called Brain in a Box. TCP Prismax was on that project. That's how long me and him have been working together. And the idea behind Brain in a Box was that every time you jumped into a system, it would recalculate all the skills in your brain to figure out if you could fly the ship that you jumped into the system with. So all of that was just basically pre-baking that and making sure all of that was good. So we want to take that idea a bit further, and there was an intermediate idea called ship in a bottle. But we want to take that even further and look at the solar system level, where we would then basically give a data packet to the solar system and say, this guy's yours now, you're the authority on this, and detach the solar system from the database completely. That way the solar system works as a function, and the outputs of the solar system get persisted somewhere at some point in time. There's a lot of hand-wavy stuff going on here, but this is the general idea. Because if we can get to that point, then we can take these guys, and also we would need to have Linux support on our servers, but that's a whole different thing. But then we could take these guys and then put them into this ecosystem where they could just be scheduled with Cube as pods. And now we have the ability to increase capacity and then isolate solar systems. Because another thing about when we actually predetermine these systems, one machine might have JITA, it might also have Amamake on it or something, I don't know. It might have multiple solar systems on it. And for things like wormhole systems, it has a ton of them on there. Like, it really depends on the activity. There's a mechanism where it looks at previous history to figure out how much should be there and then schedules accordingly. But yeah, ideally, we want to get to the point where we can take these, decouple the data piece of it, and then schedule them somewhere else. But that's always contextual to the domain that we're in, which is why we're very interested in the simulation frames, because that's the primary thing that the SOL nodes are doing, sending out simulation frames for what's happening on grids that are inside of that solar system. It also opens the door to maybe we don't break down solar systems, but we break down grids, and we reinforce grids instead of solar systems. I don't know if that answered your question. I started rambling a bit.
That could get very, very interesting when fights just randomly break out. But
Yes, yes. And then having the data context bit to it would allow us to then migrate those and be like, okay, this just escalated to 600 people. Tie-dye 100%. Move. Okay, go. And give it more power. But we also have more ability to give more CPU on the fly instead of cube. Maybe not memory, but that's a different problem to solve. But yeah, that's the end game. That'll either happen in my career at CCP or lifetime, depending on how that goes. We'll see.
I'm curious on like ESIs in the hopefully modern kind of bucket. Is there an opportunity to shift some of the design patterns, like for ESI consumers are typically polling endpoints like endlessly, to have maybe a pub sub kind of feed for some of the like very popular like notifications endpoints?
I'm going to answer the cultural side of this, and then I'm going to hand it over to you guys. So ESI is actually the infant version of Quasar. It is where we pioneered a lot of these techniques with message bus systems and those kind of things. And one of the things as time has gone on, because of priorities, companies, blah, 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 all the boring, not technical stuff, what really ended up happening is that we had to figure out how do we make ESI a first-class citizen in the development process and not have it be this extra thing that people have to learn. As we're building new services, like we'll take corporation projects, for example. What actually happens is, for corporation projects, it gets created, and then it's already making an API for the public gateway. And everybody has access to the public gateway. All clients are connected to the public gateway. Technically speaking, you can automate how you're using corporation projects through the public gateway. It's all just gRPC. Now, it's not friendly. We put a lot of things in place to make that not the path of least resistance. So it crossed our minds to basically say, okay, well, maybe the next evolution of ESI is the public gateway, and we switch everybody over to gRPC. Immediately split the crowd. Because the other point of ESI is that we want that to be accessible. We want everyone to be able to access that. That was kind of the whole premise behind the Excel plugin, those kind of things. Different layers of accessibility, right? So we chose to keep with OpenAPI in that route for the accessibility route in those cases, because also there's a bit of a different paradigm. Not only were we trying to figure out how do we get the technology to be a first-class part of the development process, but how do we get it to be a first-class part of the design process? Because there's a big question around not only, should we export this information, but what parts of this information should we export? Because we've seen all sorts of fun ways people have abused that. If you want to hear some of those, catch me later, we can go over those. But for the main reason that I'm telling you all this backstory is for the service gateway. The service gateway has notices. That's how we ship out the ship skins. That's all push information. Super cheap, blast it out there. If you get it, you get it. If you don't, well, whatever, it's fine. You'll get another one at some point. That would then provide the ability for application developers to get just a constant stream of information. The paradigm shift there is that the public gateway is built per user. So you would only get a stream of information for characters that you owned. And this would make it difficult for the paradigm shift of if you have something like zKillboard and you were trying to aggregate all that stuff. The paradigm just wasn't there. So there's a lot of other stuff that we need to think about, those kind of things. Which brings us back to an old conversation that we had, and I'll point to CCP Pinky to continue that.
You want me to talk about it? Can I?
Sure, yeah, go for it.
No, so the main thing about ESI, it is split in two worlds. We have data that is mostly static, rarely changing, and you have event-driven data. The event-driven is hard to get from a data lake because it's difficult. But the pooling you have to do is also annoying. And just the best example of that is both the online endpoint and the location endpoint. Bit of backstory, 70% of our requests is those two combined. It's just insane. Everyone is pulling them every 6 seconds, and they are most of the time identical in response. So what system are you in? This? Yeah, I already knew that. And you ask it every 6 seconds over and over. What you want to know is, did I change systems? That's the only piece of information that you want. There are two sides to that coin. One is bandwidth. There's a very high amount of bandwidth going forward. New connections, especially new connections, are expensive. But the other side of it is, it's very inefficient for us. We can cache the data for 5 seconds. After that, we have to let the cache go. We have to go to, in this case, lucky enough, a Quasar servers for the online status. But for the relocation status, I believe we still hit the monolith, asking, hey, where are you about? It's expensive. So we rather push the data to you. How to push the data is a very good question, because OpenAPI does not facilitate it. HTTP2 had for a while, they had this thing like server-side pushing. All browsers removed support for that, so it's a very bad choice to pick. So then what? Well, there are two choices. One is gRPC, but having people learn gRPC in the web world is a challenge. And the other one is WebSockets. So we're looking into the possibilities there, what we can do there, but it is a more efficient way of getting information to you. This is not short-term, just to set expectations. This is not short-term that we can do this. But it is something to actively look into, especially for those two endpoints, because it will both help you and it would help us a lot. Does that answer the question a bit?
Do you all have any plans to use cloud services to take some of the load off, say the Sol nodes or the data lake, or to augment what you all have currently deployed for Quasar?
Yes. So this is what I mean when I'm talking about simulation frames. So one of the most expensive things that we do during a massive fleet fight is about 30% of that is broken up into serialization. So basically making the message in byte form. It's broken up into multiplexing. It has to then go and send that message to each client and target that client. Then there's the actual transmission of that, which is sending it over a socket, those kind of things. All of this is about 30% of the CPU time inside of one tick of a fleet fight. Now, when we're looking at Quasar and how we've integrated gRPC into the Eve server, we get serialization for free because ultimately when you generate protobuf when you generate Python from protobuf and you generate C++ from protobuf, they have this really cool mechanism where you can bind those together and you marshal the data as it's put in a Python object straight into a C++ object. So then the serialization happens immediately on a separate C thread before we transmit it, and that's the other part of it. Now, the multiplexing comes in where we have this glorious guy in the middle here. We can basically tell him, I want, oh, actually, that's a lie. This guy, because he's going to the clients. So we tell Nats, I need everyone in this grid to have this simulation frame. Go. That means that we only tell it once from the server, we serialize off thread, and we transmit off thread. So if we were to snap our fingers and solve this problem this way, we could move simulation frames off to Quasar, and that would give us a 30% performance increase for fleet fights. So there are certain things that we can do there, coupling that with some of the longer term things like we were talking about earlier, with disconnecting the data context and allowing them to run on their own and maybe running only grid specific as opposed to solar system specific. That starts adding up and adding up. Closer and closer we get to basically decomposing this into better composable APIs so that we can kind of break apart where the intense pieces are and potentially get to a place where we don't have tidying, allegedly.
I mean, also anything that we have already added to Quasar is already load off of the sol nodes. All the features that we made there are already things that we didn't make in the monolith and therefore are using CPU.
Right, that's a good point.
That
Like,
stuff.
if we were talking about location, for example, the Eve server is the authority on where you are. That will never go away. But what we've done to mitigate that is we process events coming from the Eve server, so we have a local cache in the Quasar ecosystem. So when you guys ask 5,000 times a second, where's my ship? We can answer that very quickly without hitting the monolith. And to Wonderboy's point, I love that dev name. All of the newer pieces, like corporation projects, all of its data, all of its processing is not inside the Eve cluster at all.
I'd be fairly interested in knowing what drove your adoption of ARM-Q as a message queue as opposed to just an event streaming service. Do you like scale of that, or do you rely on the at least once delivery, or what did drive that? Because you mentioned Azure Event Hubs earlier, so.
Yes, so Event Hubs is primarily because that's what our data engineering team is using. And they can do more interesting things because they might not process all the data, but they'll store all the data, and they can use cursors more efficiently than we can. Because we don't need to know the history of everything, we just need to know roughly the current state of something. Ultimately for RabbitMQ, it was because we had not entered the message queue space, and we didn't know what we needed and what we didn't need. And RabbitMQ lets you do all sorts of crazy topologies. Matter of fact, NATs didn't exist in the first version of the public gateway, and that's where we learned the limits of RabbitMQ. Because every time a client was connecting, it would create a new topic, it would create a new binding, and that was thrashing on RabbitMQ, and it just could not cope with that kind of thrashing, because ultimately with RabbitMQ, you don't want to thrash channels and connections and bindings, that bad things happen. And so we switched over to NATs, because NATs is very opinionated with how these things work. NATs is right up there on my list with Redis on amazing pieces of software that just do what they're supposed to do. But RabbitMQ does have all of the bells and whistles in place to allow us to dynamically build out event-based systems. And I think the nuance there is when we're looking at things like Kinesis or Kafka or whatever the case might be, there was a lot of complication around sharding and partitioning, and I didn't want the developers of the services to care about any of that. And that's kind of where RabbitMQ helps out quite a bit, because ultimately we could target topics and that could be completely dynamic. Now that is a double-edged sword. There are definitely events that we have that are just dev null, and that shouldn't be maybe, but I think this is kind of why we originally went with that. The first versions of ESI were actually running in GCP with PubSub, so they're stupid, simple HTTP pub sub, but we quickly got to a place where none of their tooling could cope with the amount of routes that we were creating. And there was also the point of throughput, because ultimately it was individual HTTP calls, et cetera, et cetera. The AMQP protocol gives us the ability, it's kind of similar to Kafka and the Kinesis style of things, but it gives us a higher performant mechanism to do publishing confirms, in the sense that, for instance, when a service, like if we go for one of the services like for career corp projects, corp projects is the authority on that and has like a DynamoDB table somewhere. And it's basically transmitting all of that. Then it would go to its service gateway. That actual exchange has a confirm in it, where it would get to here. Oh, I got a wobbly box there, but so the corp would send an event of like, hey, this progressed, whatever the case might be. But before it got here, there's actually state on our gateways, and it will disqueue what's coming from the services, and then that gets confirmed back. That way the corp service doesn't need to keep that event in memory or any deal. It's like, great, you have custody, awesome. That's because we stole it from RabbitMQ, because RabbitMQ does the same thing. It's not part of the AMQP protocol per se, but it's part of their extensions in RabbitMQ, where ultimately the same thing happens, where we get a confirm that comes back that basically tells our gateways, you don't need to worry about this anymore, I've got it, and if it breaks, it's my problem. And that's kind of the biggest thing that we have with RabbitMQ, and we'll probably move a lot of the request responses into NATs because just how ephemeral they are, and RabbitMQ is just better at making sure that the data is contained where it needs to be. Because we've had many situations where we've gotten called at 3 in the morning and it's like, oh, this queue has 50 million events in it. Neat. And then it goes and burns through all of them. And I think the one that happened recently, people saw where corporation projects weren't progressing. Oh no, it was daily goals weren't progressing. But then we burned through that queue and everybody got all those things that came out of that and so on and so forth. So it gives us this resilience that when something does inevitably happen, we can still flush through all of that. So to go back to the original question, I think the main thing is a combination of, we didn't know what we needed yet, but we needed to be able to have the area to learn about what actually would come out of applying a message queue paradigm into EVE Online.
Cool, thank you.
This might be a good segue into talking about the at least once delivery of events that we have. We got to be a little bit careful when we're processing those.
Oh, yeah, so the difference is we have 4 different primitives in the ecosystem. We have events, request, response, and notices. Request, response, and notices are best effort. And for those of you who don't know, that phrase in networking is terrible. That phrase actually is bad, because best effort means I tried once.
May or may not get.
Yeah. Depending on solar flares, who knows, whatever. But with our events, that's the other piece. We wanted to guarantee that it would at least get there at least once through the system, or we would know exactly where it was in the ecosystem so that it could be delivered. This might be duplicated. We have to dedupe things because deduping is a whole other thing. But yeah, is that what you're getting at? Yeah. So we have those different quality of service for those different primitives. Everything that's in the public gateway is best effort. So if you make a request from your client, yep, we will get to your request in the order that it was received. Maybe.
Hi, I work primarily with firewalls. I'm always interested in how the bits and pieces are connected and secured. And my question would be if the network you have is like segmented with like firewalls or anything, or if it's just like one big network. I think we can stop talking now. It's fine. No, I'm just kidding. So this is kind of why we talk about east-west traffic and north-south traffic. The only thing that has, what we've tried to do, we kind of let the cat out of the bag with RabbitMQ too early, so people are directly connecting to that, and we don't want that to happen. But when we introduced NATs, we made sure that the public gateway was the only thing that could connect to that. So we do have kind of limitations inside of Kubernetes on what can connect to that. There's also users and passwords, and we use MTLS to connect to that cluster as well. So if you don't have a certificate, we do dynamic dispensing of certificates through, if you've heard of HashiCorp's Vault,
We use dynamic secrets with them quite a bit. And that's how we control who can connect to those resources. For the main east-west traffic, there's not really much partitioning on a network level other than access through either user pass or MTLS. We rely heavily on MTLS because it not only secures the connection, but it also solves for the service token conundrum as well. It does both in one. For those of you who don't know what MTLS is, it's mutual, thank you, mutual transport layer security. So normally when you're going to a website, it says HTTPS. That's probably TLS, so it's encrypted. Mutual means both the server and the client go, are you who you say you are? I can cryptographically confirm that, yes, no. So even our internal services are doing that with our other internal services. As far as the public gateway is concerned, it's one of the other benefits of how we've designed Quasar is that none of these other services, they don't need to have load balancers. There's nothing to connect to those. So the only front door we have for that ecosystem is the public gateway. You could argue that the other front door is ESI, but that's going to be their problem now. So it's kind of a smaller surface area more than partitioning.
Thank you.
Follow up to his question, if NATS is essentially, and the public gateway are essentially being your DMZ, are you going to ultimately transition to full zero trust?
Possibly. So this is the other tricky part. Like we split up the domains in protobuf. We have an Eve public domain and an Eve domain. That way we know that anything that is in the Eve public domain, the players will have access to. Anything that's in the Eve domain, they shouldn't have access to. We might accidentally ship the definitions every now and then or whatever the case might be, but ultimately they should have no way to operate on those. So in a sense, yes. The tricky part is that when we're talking about the quality of service of the messages, we ship Eve requests and responses through RabbitMQ right now because they're in that east-west traffic, whereas the request responses for the public gateway are the north-south traffic through NATS. If we'd want to use NATS again, we'd probably, we don't know yet, don't quote me on this, May. We might dump those into the same cluster, or we might put them into a separate cluster to maintain the ability to get closer and closer to zero trust in that regard. We'll see. We're not sure about that yet.
It is funny that you drew NATS in north-south and then RabbitMQ in east-west. It is exactly how you say it is.
I've rambled this into the existence a couple of times. You gotta wait for. What's your dev name? CCP Fitbit.
CCP step count. Another sort of infrastructure-related question then. Where do the CDNs fit in to the way situations are distributed, the caching? Because obviously there's Cloudflare somewhere involved. Mm-hmm. And so yeah, where does this then fit into the way you then process the data?
So there's a couple things there. One aspect of this is DDoS mitigation, and that's protecting our data center with Cloudflare. We use Shield Advanced for our AWS endpoints. So there's kind of a partitioning going on there, just because it's an all-in-one thing, and et cetera, et cetera, et cetera. Don't really know how that's going to play out, but it makes it clear which way path those are going to go. For the CDNs, we're actually looking at changing how we do development a bit with the data that we have. You guys are familiar with the static data export and those kind of things. We're tinkering with an idea of formalizing that a bit more. There's a cousin of protobuf called flatbuffer, which would allow us to define that and basically ship that out, and then you guys could generate code from it. We generate code from it, all these different kinds of things, but also do that in tandem with a CDN. So we don't ship all of the data in the client install or through MachoNet or through gRPC. At some point in time, we draw a line and say, hey, this is too big, just go get it from the CDN, and we version that and those kind of things. That's still in the primordial ooze phase. We'll see how that plays out when we're changing how we develop things a little bit. but that's kind of what we want to shift to. You're probably going to see more reliance on the CDN in those pieces. It also gives us some benefits here and there. Like for instance, right now, localization files are a gig for the client install. We could remove a gig from the base client install if we chop those up and only ship those when you change your localization to a certain value. So there's a lot of wins there as far as installation size and as far as like how much we need to transmit real time. Like this goes back to the culture of how Eve was originally built. Because it's Python, you want to ask a question that has a lot of information on the way back. So this is why sometimes when you click the market, it kind of has a little bit of an aneurysm and then shows the market window, because it's trying to get all of that information. But if you look at how we're developing more of our newer features, there's latent data loading. Like you'll see things pop in or fill in the data as it comes through. Skinner, the Paragon Hub is an example of this, as we're slowly loading data in for like the renders of that or what the price values might be, et cetera, those kind of things. So there's a bit of a cultural shift in how we build those things as well. And that will affect how we use the CDN and how we actually distribute information to the clients.
Regarding your changeover to protobuf and flat buffer, does this obsolete the old like blue Marshall side of things for serialization, or is that still going to be tangled in this? Considering,
God, I hope it gets rid of it. Yes. Like,
okay, cool. Because
like,
reading that stuff is terrible.
Yeah. So a lot of like to kind of highlight that a little bit more. Like there are a lot of things like again, localization is a good example of this. Localization is just a giant pickle file. Which is just like a native mechanism for Python marshalling, or serialization, I should say. We have those sprinkled here and there. Even the information that comes back from the database all the way to the client is like a wrapped OLEDB structure all the way back down. And so those are hidden inside of other C structures. And this is kind of the other motivating factor behind Quasar in defining those APIs, because that prevents us from expanding and creating more interesting pieces and building out more interesting bits of the sandbox that connect together, because they're all hidden in this metal ball that we have to melt down, get a piece out, and then melt it back together. So yeah, hopefully, ideally when I say the left side of this will disappear in the future, we'll get rid of all of those things as well. But that is going to be a very long play.
Really time for one more question, I think.
Hi. So you talked a lot about your transports like gRPC and MQTT and so on. I was curious what you're using for service membership and discovery, because in my experience, this is just as, if not more important, for things like reliability and performance.
Service membership and discovery. So I struggled with this originally when kind of architecting the system, and then I have a controversial opinion on that. Service discovery doesn't actually matter, because ultimately when building a distributed system like this and you talk about like what happens to my consumers, you don't care who the consumers are. The consumers need to be backwards and forwards compatible. You need to only make backwards and forwards compatible changes. So the discovery aspect of this kind of started falling away, and then actually pushed me away from service mesh technologies towards message queue technologies, because ultimately there was no need. Like if somebody consumes, if I'm answering a request from somebody and I need to change the response of that request, I need to make that backwards compatible, or I need to do it out of band and deprecate and those kind of things. And we also have systems built into that, so it's kind of an inverse of that, where we use the ubiquitous language of protobuf. Every time we build a service, it has another CI configuration on it, where it will get latest of everything and build against that service and run all its tests. So that service will then get an alert, hey, you're now relying on a deprecated request or something. Like worst case scenario, completely breaks because it disappeared and we did something very wrong. So it's more on the onus of the consumer than the publisher, because we don't want to anchor everything, because we're gonna have more and more things built up in this chain of dependencies. So we don't want to anchor those in something. We want to have the agility to move those around and then shift the other pieces independently. So there really isn't this service discovery. I think the closest thing we have to service discovery is you go look at our Eve proto repo and try to find a request or an event that you want, much to the dismay of our data engineering team. But that's primarily where we've landed so far.
That's also why we don't have any heartbeats in our services. There's kind of a trust there.
Yeah, we also became allergic to some of the original mechanisms inside the Eve cluster, where it heartbeats, and if it doesn't say anything for 1 second, it shoots it in the head. Actually, it doesn't shoot it in the head. It sends a message to the DB to tell it to shoot itself in the head. So we kind of went away, this is one of the things that we had with ESI originally. ESI did have a mechanism to kind of see if the server was up, but if it missed that, then ESI would be like, la, 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 and would just not answer anything. So we kind of got rid of the service discovery aspect of that to basically say, if we can either answer it now or we can't. And now things are blinking at me.
Oh, you're done.
All right, thanks, guys.